Okay, so ready for the next session? We're in the home stretch for today, and now we have. So you're gonna have to help me with your last name because I've heard it pronounced 8 different ways.
I know, it's just Lerche.
Lerche,
Mm-hmm.
like you rang.
Yes,
okay.
But it's spelled with L-E-R.
Right.
German.
So we have Carl Lerche here.
Lerche.
Lerche.
I've heard that many
Lerche.
times. Not that yet.
To talk to us about how to make your Ruby codes fast.
It's true.
Here we go.
It's going to be a short talk because it's not possible. No. Yeah, so who am I? I was introduced. Name's Carl Lerche. I work for Engineard, and my job right now is to work on Ruby on Rails, get it to Rails 3. We have like 2 weeks before RailsConf. It's pretty busy. It's a pretty awesome job. I work with Yehuda. And I've also worked some on, the new solo offering that Engineard just launched. It's a pretty awesome platform for managing Rails deployments on EC2. And last plug, we're hiring right now, so if you want to work for Engineard, find Joe Arnold. I don't know where he is. Ah, sweet, there he is. All right. So, does Ruby scale? For some reason, I feel compelled to talk about scaling whenever I talk about speed. Everybody seems to do it, so let's just put that to rest. Yes, it does scale, and so does lol code. Turns out, yeah, scaling is not related to the language, maybe somewhat to the VM, but you can build, run Ruby on different virtual machines, so it's not really relevant. And scaling has, completely different from speed. In fact, they can be completely opposite. Sometimes to write, scalable application, you have to write slower code. So let's not talk about scaling anymore. Okay. Is Ruby fast? Which is the main part of the talk. Well, let's check some benchmarks compared to other languages. You might search for, the Great Language Shootout, and Ruby scores somewhat low down there, although, JRuby's 23rd. Right above PHP and Perl and Python. So, doesn't look good. What can we do? Well, we can look a bit higher, maybe pick something from the top. Number 11 looks nice, so that's my conclusion. Any questions? No, but seriously, Ruby really is fast enough for the vast majority of use cases. There are really only very few cases where you might need something faster, like C or something else. Odds are slow code is your fault. Yes, you write the slow code. There are plenty of Ruby idioms that, don't look at that. Plenty of Ruby idioms that, like Yehuda mentioned earlier, nothing's really free because of Ruby, but if you keep them in mind, when writing code, you might be able to avoid a lot of slow bottlenecks. All right, so how can I write fast code, which is really the body of the talk? Let's get started. So the first thing to do is write slow code. You want to write, not so much slow code, but well-structured and clean code that's well-organized, easy to understand, easy to refactor, and not even worry about performance, really. I mean, you don't want to try to write slow code, but don't worry about performance the first time around, because odds are you don't even know what's really going to be slow. I've done this plenty of times. Like, I'm writing Ruby's I got to make this as fast as possible without actually having the finished product, and I put lots of effort into little bits that actually don't matter in the great picture, the whole application. So first, write the code base, write it slow, doesn't matter, and then 2, use science. That's my little science guy. You don't want to stab at codes and just go wildly, try to optimize with no benchmarks. You don't know, without actually having a goal in mind. We do computer science. Half of that is science, and science gives us a whole bunch of techniques which really have gotten us, computers and everything. So the scientific method is probably the most important tool that science gives us, and we should use it. I mean, if it can put men on the moon, I'm sure it can help us write faster code. So I'm going to go over the points really quick and then rephrase them in context of writing code. So first is defining the question. You cannot know if you've answered that question unless you know what that question is. And little tip, it's not, how do I make my code fast? That's not, it's got to be more specific, but we'll get to that. Number 2 is gather information. You need all the related information to be able to answer that question. Then you form a hypothesis. Take a stab at answering that question given the information that you have gathered. Perform an experiment and collect data. Analyze and interpret the data, and then publish the results and retest. So let's put that in context of writing Ruby. So why is my code so slow? I'm not going to pronounce that. We're actually going to, when we get to this point, it's going to be a lot more specific than why is my code slow, So let's get there. After you ask the question of specifically, why is my code slow, then you find out you have to gather all the information, which really is where's all the time being spent? Where's all the memory going? You need to get as fine data as possible so that you can answer the original question. Then, once you find out where all the time is being spent, you need to actually try to form a hypothesis. So why is this chunk of code where all the time is being spent so slow? Eventually, you're going to have to try to answer the question, and hopefully you'll have as much information as possible. And you change the code, collect some benchmarks before and after, and compare the metrics. If this is actually an easy step, if the after metrics are slower than the before, then you have not successfully sped up your code. And then deploy. Once you have solved the problem of speeding up a specific bit of code, then you deploy your Ruby to the world. So, my app feels slow is not defining the question. What does slow even mean? You can't really optimize unless you know what exactly you're optimizing. So you have to really phrase the question in such a way that you can answer it. Like, why is a specific Rails action taking more than 100 milliseconds on average? This is a more specific question that you can actually gather information about and set up benchmarks and actually know when you answer. It's like, okay, I'm going to try to make this under 100 milliseconds. Why is 60% of a Merb dispatch cycle in the content negotiation phase, which is something that we came across a few months ago. We just running our benchmarks say, oh, all the time is being spent figuring out whether it's an HTML or JavaScript request. Maybe, I know a lot of people have had this problem before. Why are my Mongo processes going to 300 megabytes of memory over, a day or so? All right. So to illustrate, the whole process, this is my demo part. It's the easiest way to do it. I just wrote this past week a little rack router thing that I'm going to try to get into Merb 1.1. It's on GitHub and everything, so you can check it I'll give you the my URL later. So I wrote the whole thing. I would try to keep it as clean as possible, and I did not worry about performance at all. And before I can actually put in use in Merb, I've got to ask myself, well, how does, I'm going to be specific here, is route generation as fast as in rack router as it is in Merb? So it's the part where you say, okay, I'd like to generate the URL for the user's path or whatnot. So I've actually, in Merb right now, it's pretty fast, so I don't want to replace it with something slower. Okay. So now that I've phrased my question, I need to gather the information. One good way to, these are a bunch of tools that you can use to gather a lot of information that you can then use later. So RBench is just a benchmarking, pretty nice benchmarking tool, wraparound Ruby benchmark. It's what I used first. I set up a whole bunch of benchmarks to compare my router with Merb's. Ruby Profiler, I'll show a bit later, using it with KCashGrind. If you're building a Rails app, odds are you have a database, and you can look at the log files, see the log files in of themselves, they give you how much time spent in the database, how much time is spent in the actual application. So then you can check your queries against explain analyze. It's a really powerful database tool for figuring out why is a database query so slow. New Relic 5 runs also have good tools. Anyway, so in the last two are for memory usage. So these are some tools that you can use, look up later when you're trying to figure out why your code is slow. All right. So step 2, okay, I set up a little benchmark script. I put up basically a route file that was equivalent in the rack router, in the Merb router, and in the Rails router, and set up benchmarks for all the common use cases. So generating a simple string route, or a route that has captures, or optional segments, or any of these things. And this is all using RBench, the first line that I took. First action I took. And I ran these benchmarks, and this is kind of the output. Like, it would tell you on the left side. I don't have enough space on the screen to list which benchmarks it is, but so basically, on average, like the simpler cases are the top ones, so simple generating from a string, and the bottom ones are the more complicated ones. So on average, it's about 2 times slower than Merb, and for the complicated cases, it's 20% slower than Rails. So, well, I've answered my original question: is my route generation as fast as Merb and Rails? The answer is no. So that's nice, but now I'd like to make it fast. So I'm going to rephrase my question. Well, what's actually making it slow? Like, where can I, how can I make it fast? Which lines of code do I have to change to make it fast? Okay. Well, benchmarks are nice, but they don't give me any of information to answer that question. All right. So next step would really be, set up a little profiler using ruby-prof. I don't know if anybody has used that before. It's it's a Ruby gem. Just gem install ruby-prof. But yeah, I set up my rack router in a new file, and I just picked one of the routes that I was generating that seemed problematic. You have to start with a very manageable bit, and I just loaded up the ruby-prof and set up just profiling around that single bit of code. And then I ran it. And ruby-prof has a whole bunch of ways to output that data so that you can look at it. I don't know. What I used to use originally, which was almost impossible to understand, was the HTML call graph, which is just a big HTML page, a big table that gave you a bunch of data, like, oh, this method ran for this long. It was like, I don't know, 1,000, 2,000 lines long, and I couldn't understand it. But there's another format that lets you output something called a call graph that you just dumps a file that you can open in KCashGrind. So KCashGrind is a pretty awesome tool to read profiling data. You can get it, it's part of KDE, but you can get it on with Mac ports, just doing sudo port install KCashGrind. So I booted that up, and I just opened that file that was output by ruby-prof, and this is the first thing that it shows me. So at first, it actually takes a bit to get used to this app, but I'm going to try to point out the important bits. So at the top left is simply the methods that take the longest, I guess. It's kind of a quick overview. Under that is the entire call stack with the little bar on the left. The big red bar on the left is the amount of time spent in that specific method, including all methods that it called. And then the column that's labeled self is the amount of time spent in the actual method without all other methods that it calls. And you can select any of the methods, and the main part will update. And you can get the calling map, which is shows all methods it calls and what methods call that one. But the most interesting thing, I think, is a call graph, because you can just get a really visual representation of what's going on performance-wise. So I just selected the first entry method, which was the URL, which we saw on the other one. So that's where everything starts. And yes, 98% of the time is spent there. So what we want to do is find the main culprit for, that's sucking up time. To do that, usually I find the easiest way to navigate is simply sort that column. This is another nice feature. You can sort all the data by almost, any which way. It's kind of overwhelming, but so I sort by self and find the method that's taking up most of the time in itself. In this case, it's array map. So obviously, you cannot optimize array map, and what we need to do is kind of figure out which concept, I guess, in the code which goes back to organizing your code well. It's like hopefully there's only one specific bit of logic that's sucking up all the time that you can then spend time optimizing. But we select this method, and we can kind of look at what's going on. It's like, oh, well, it seems that most of the calls to array map happen in, rack router condition generate from segments. So let's look at that method more. So you can double click on that little box and recreate it. And yeah, pretty much 87% of the entire time is spent in this one single method, and it makes a ton of calls to various enumerable methods. So this pretty much tells us that there's a lot of logic that's happening here that's taking up all the time. It seems like a good place to look and maybe spend some time trying to speed up. All right, let's take up the look up the code, and there's a lot happening here. Really, I get every time I want to generate a URL. In this case, I get a bunch of segments, and it's a recursive, so it's a loop, and then it recurses over itself. So a lot of time is being spent here. So, okay, my hypothesis then is going to be, generate from segments is the main culprit. And more so than this, my hypothesis is, well, most of the logic that is happening in this method can be removed and, doesn't need to be called for every time I want to generate a route. I'm going to say, okay, well, I can remove most of this logic and throw it somewhere else, like boot time or something. So perform the experiment and collect data is basically going to be, well, I'm going to tweak with the code, play with it, and if you want more details, unfortunately, I only got 30 minutes. So you can check the Git logs, which I will give you the URL for at the end. And so I play with the code, and after I'm done, well, I run the benchmarks again. Okay. So I managed to speed up everything about 2x. I'm going to talk a bit later about how I did it once I give you some specific tips. And interpretation of the data is I win, and publish results is, I use Twitter. So this really, is kind of the process. I went over the whole scientific method, the steps to do it. And if, for example, I hit this and I did not manage to speed it up, well, then I restart from scratch. It's like, well, I failed. Let's start again. Gather more information, reform a new hypothesis, all that. And yeah, the main tool I actually I'm used for this whole process is really KCashGrind, and I highly recommend that you all try it out and just install it and take any bit of code and try to play around with it and figure out what's going on performance-wise, because it's going to take a little bit to get used to if you actually want to do it. And what I showed you before was a pretty simple call graph, so I just thought I would throw in another example that's a bit more complicated to hopefully demonstrate that you can actually drill down and get all the information needed. So I mentioned earlier that one question might be, why is 60% of the request time happening in content negotiation or a Merb request? So back then we set up a bunch of benchmarks and set up profiling and set up a controller action that try to determine whether the request was HTML or JavaScript or XML, I think it was too, and ran a request, a few times, and dumped the call graph. And we opened it up, and this is what it gave us. It's a bit, there's a lot more happening here. So this is where it's open, and it's the start of the dispatch. So let's sort again. Let's see. Oh yeah. So then I actually selected the index where it's happened, because that's where all the time is being spent apparently. So what I wanted to show is not only can you open the index there, but there's also a tab up to view the source code, and KCashGrind will also annotate the source code with performance, with profile information, and tell you about where everything happened. So here again, there's a lot of logic happening in array map, so content negotiation. Not much time is being spent in parsing the request, but most of the time is then happening in array map and other craziness, which turns out to be a somewhat similar problem to the URL generation thing I showed earlier. So again, speed up the code and benchmark and make sure we actually did it. Okay. So that's the general process you might take if you're before embarking on trying to optimize some code. So more specifically, let's talk about some specific things you can do in Ruby to optimize your Ruby code. So before I move any further, I'm going to put a big disclaimer here. A lot of the specifics I'm going to mention, some people don't just say, okay, I have to do everything that I saw, in the following slides. Because I don't want anybody to leave here and say, oh my God, I did everything bad that I said here. I've got to go rewrite all my code. No, you don't. Just what you want to do is actually go through the whole set of steps, and then during the gathering the information, maybe keep that in mind, like the specific Ruby idioms that are slow, and to maybe figure out quicker where things are happening. And yeah, so science. All right. So I would say the biggest problem factor right in MRI is the garbage collector. As in, if you trigger the garbage collector way too much, you're going to end up with huge amounts of time wasted cleaning up objects. So some specifics of the garbage collector. It's actually a conservative mark and sweep garbage collector, and every time it runs, it has to stop the entire world, which means every time the garbage collector is running, none of your Ruby gets executed. And it can take, on a maybe 50 to 100 milliseconds each cycle. So the goal is to get the garbage collector to run as little as possible. And the way it works is, the way object allocation works generally is, Ruby boots up and it gives you 8 megabytes of memory to play with. And every time you try to create a new object, Ruby says, hey, do I have enough memory to store my Ruby object? If it does, you're good. It just allocates the memory to store your Ruby object. And if it can't, it's going to first run the garbage collector and try to free up memory. If that still doesn't free up enough memory, it then tries to grab another 8 megabytes chunk. So, yeah, you do not want to create an excessive amount of objects during your critical path. Because the moment you use up too much memory, the Ruby stops running. So, some words of caution, avoid creating unnecessary objects. One way to do that is to know the differences between the various variants of Ruby methods, like reverse and reverse bang. Usually, a lot of Ruby methods that will duplicate your entire object will have a bang method. And yes, duplicating an array with 3 elements in it does not really matter. You only really need to keep this in mind when you're dealing with large arrays. Like maybe an ORM might have an array with a whole lot of objects in it, and it does not want to duplicate the array every time it wants to perform an operation on it. This was actually, from this kind of code was sprinkled throughout Data Mapper at one point, and was creating way too many objects. So one thing, you really want to know which methods already dupe your object. Like values does not modify the original record, so you do not need to dupe it before returning values. Let's see, and then know when a method actually dupes it, so you do not need to redupe it twice. So user's map will create a duplicate of a fresh object, will not return the original users, so you can just call bang on it and not affect the original user's object. Another way you can avoid creating, am I running out of time? I think I am. Another way you can avoid creating a lot of objects is using something like data mapper's identity map, which whenever you run a data mapper query, you can, it hits the identity map and checks, hey, did I already initialize this object? Do I have it somewhere? If so, let's not create another version of this database record. Let's return the same one. Things like that will, drastically reduce the number of objects created, which can be a lot. It will not hit the database as much and save a lot of time in general. And beware of modifying large strings. So every time you deal with an array, for example, when you dupe it, you you don't actually duplicate all the elements. It's a shallow copy. So usually that's pretty cheap unless you're dealing with a large number of elements, like thousands, which maybe you are if you're building a CSV library or something. So, but with strings, every time you duplicate it, you have to duplicate the entire thing. You can't do a shallow copy of a string. So instead of always duplicating the string and then reassigning to itself, maybe you try to concatenate instead. Try to concatenate, and let's see. And also, don't do parse time operations in the runtime. So I see in a lot of Ruby code, people will concatenate strings just so that they're not one big line. You can just put another string on the separate line and have a little slash, and parse time combine the strings. And yet another memory thing is beware of closures. Closures are cool, they definitely are, but they'll keep in memory all the local variables that are available at the time the closure was created. So if you have a huge object right before you create a closure, as long as that closure is in existence, like assigning it to constant, that huge string right before will be kept in memory basically permanently. All right. Being lazy. Let's be honest. No code is faster than no code. It's like one thing Merb goes by. Merb is lazy. So everything in Merb we try to not do until you actually request it, like cookie handling. Will not actually run any cookie handling code unless you want to check the cookies, sessions, extracting request parameters, everything. So the less we actually do during the critical path, the less time is spent, doing that. One way you can avoid doing extra logic is memoizing in the reader. You can just have a little instance variable and then do all the logic in a little block after. So the first time you access params, all that logic's run. And if you notice, the very first call to merge, we used the merge without the bang. Then every subsequent call, we use the bang method because we want to modify that h instead of using the non-variant and duplicating the hash. You can use procs as method arguments instead of just the argument. So, like for example, if merb logger info will not always dump to the log. It will only dump to log if you're in the info level. So in production, nothing will ever happen. But if we dump the params to the log, every single time this line is called, the params get evaluated, and then, like you saw on the previous slide, it's actually pretty complicated. So what we switched it to was putting that inside of a block that gets you called if you want to actually do the logic. So the filter params is only request params is only evaluated when we are actually dumping them to the logs. And yes, data mapper is lazy. The way they do it's lazy array, and everything else tries to inherit from lazy array, like a collection or results from a query or associations. So when you run a query, the query is not actually run until you try to pull objects from it, which sometimes you don't. And also adding to the collection, you might not. Well, you don't want to pull the entire collection if all you want to do is add to it. So don't actually concatenate until you're loaded. Try to be lazy. And one way is lambdas. So lambdas are sexy but slow. It's true. So like I showed before, there are actually times you want to use lambdas, but you have to keep in mind that they are more expensive than a method dispatch. And just to specify, proc is not a block. There is a subtle difference between the two. Like for example, in these two, the second version is about 6 times slower. And yes, this is a micro benchmark, but micro benchmarks do add up. If you're calling this 2,000 times, it's going to be 2,000 times a 6x difference. The reason why block is so much quicker than the proc is that the block can only be evaluated in the context it was created. So when you actually assign the block to a variable, it's got to save that context off, so you can pass it around as an argument to another method. And just to specify define method, I don't know if you've ever used define method over other versions. It's also creating a proc. So you get the same overhead. And one place I've seen procs somewhat abused is the namescope. So I know namescopes are great, active record and everything, but this is a code I pulled out, and I can see 3 nested lambdas, plus you can pass in the lambda as an option, so 4 nested lambdas possibly for each name scope, and then you can stack them. So I decided to try to compare the two. These are pretty much feature-wise, these are exactly the same, and using the name scope, including the full request to the database and coming back, is 30% slower. Now, yeah, take this with a grain of salt. I'm not saying don't use name scopes. I love using them, but if you need most performance possible, maybe that's something that you might want to consider. Yeah. And the last, because I think I'm running out of time, right? The last trick I want to mention, which is what I use in the original route generation, and is compiling your code. So iteration is slow. Ruby's AST is fast. Obviously, when you iterate over an array, it's got to compile. Each has to move down to the Ruby's AST and then run that too. So what if we could, instead of iterating in Ruby, move it down to the AST? Yes, class eval for the win. So the trick is to expand logic and iteration into Ruby code by generating a method and then class evaling it. So, for example, callbacks is one way we do it. We have before foo and then call the first, after foo, call last, around foo, hugs or whatnot, and then inside. So when you declare your callbacks, what it could do, for example, is compile a method that then calls the callbacks in order that you specify. So instead of having an iteration over the callbacks, you can it's just normal Ruby code. It speeds it up quite significantly. And just for the sake of to show you what happens, this is an example of how in the route generation, I would take a control action and ID route and compile it down to a single string interpolation, which is how I got that much speed out of it. So yeah, but you're not supposed to look at this. This is not what you're going to see in in the Rails source code, for example. This is why you want tests. Oh, and that's true. This is why you don't write speed first. You write good code with lots of tests, so that when you do crazy stuff like that, you can hopefully have your test suite catch anything. So, all right, that's about it. I guess I have time for some questions still. I'll take one question. Yes.
So, the main proc has the main block has an argument method, which showed earlier. Name proc.
Oh, yes.
No, the ampersand block.
Yeah.
Right?
Where was it?
So people advise against it. I've heard it before, now you did also. And the only workaround you can do is pass it down.
So what I'm not saying is avoid using it. If you need to use it, do it. But don't, if all you're doing is yielding and you don't want to create the proc, then there's no reason to do it.
Oh, there was a commit to Rails that got rid of tens of them. Valid users got rid of them because of performance issues. It introduced really on the code a bunch of conditionals. Conditionals to check it.
Okay.
Something is so. This is a trade-off.
It is.
I mean,
it's always a trade-off
for performance. It's a nice feature of Ruby. I want to use it. I want to use ampersand block, and I get a feeling. What if this will be a bottleneck?
Or what?
What if this will turn into a bottleneck? So,
what if it turns into a bottleneck?
What if the usage of this Ruby feature turns into a bottleneck? In my
Well, this is. It is 6 times slower, but it is a really small amount of time compared to a lot of other things. So, in Rails, I guess we're trying to remove anything that could be a performance just because Rails should be as transparent as possible. Hopefully your application is not slow because of Rails. And really, the main point of this is, if you don't actually need to use it, I would personally still use ampersand block if it made my code a lot prettier, and not worry about it until later down the line where where I actually notice it's causing trouble. So again, I would if it made my code prettier, I would use it until I noticed it was a problem. Does that make sense? So if it would take a lot of calls for it to really become a bottleneck, but it can happen. Like in Rails, if you're calling a method a lot of times and you need raw performance, I will take a bit uglier code to get that performance back.
Okay, great. Thank you very much.
Oh, thanks.